Assalamu alaikum everyone. Welcome back to my channel. In last video we have covered our introduction to at Proteus, Arduino IDE, and ATMEL Studio. So in their installation guide and some uh, you can see blinking code. And now we are moving into lab 2, which will be covering introduction and implementation of assembly language programming on ATmega 338P using AVR Studio. Now we'll be concerning AVR Studio and implement it on Proteus simulation. We can see use here. The objective of this lab is to get started with assembly language and programming for microcontrollers to learn about the registers and commands for AVR assembly language. And third is to learn the basic criteria of writing assembly language and implementing it. Perform different tasks in order to enhance the ability to write assembly code for more efficiently. Software requirement is AVS Studio and Proteus, and we will have the hardware implementation as well. We will use Atmega 328P breadboard, push button, LEDs, resistors, and connecting wires. So, what is assembly language? Each personal computer has a microprocessor that manages the computer arithmetic and logical control devices. So, a processor understands only machine language instructions, which are strings of ones and zeros. However, machine language is too obscure and complex for using software development, so the low-level assembly language is designed for a specific family of processors that represent the various instructions. Okay, the advantages of assembly language is having an understanding of assembly language makes one aware of how program interface with OS operating system processor and BIOS, how data is represented in memory and other external. So basic advantage of assembly language is that you can use the interface with operating system processor, and you have see how registers and instruction are executed at the back end of the processor, and instruction access and process data and program access is middle devices, and it requires less memory than the C++ or C, and less execution time. It allows hardware specific complex job in easier way. It is suitable for time-critical jobs and more suitable for writing interrupt services routine and other memory resident programs. Basic feature of PC hardware. The main internal hardware of PC consists of processor, memory, and register. Register a processor component that hold data and address. To execute program, the system copies it from external device into internal memory. The processor executes the program instructions. The fundamental unit of computer storage is a bit. It includes on or off, and a group of 8 related bits make a byte on most of the modern computers. The processor support the following data sizes. The word is a 2-byte data item. Double word is a 4-byte 32-bit data item. And quad word, which have 4 word and 8-byte 64-bit in a data item. And paragraph we have 16 byte, and kilobyte have 1024 bytes, and as well as megabyte has 1,040,576 bytes. It means that 1024 byte kilobyte will have 1 megabyte. Processor register. These are 10 32 bits and 6 16-bit processor registers in IA32 architecture. The registers are grouped into three categories: general registers, control registers, and segment registers. The general registers are further distributed in divided into three groups, which are data registers, pointer registers, and index registers. AVR register. AVR is an 8-bit microcontroller, therefore all its ports are 8-bit wide. Every port has three registers associated with each one having size of 8-bit. Every bit in those registers configures the pin of particular point port. Bit 0 of these registers are associated with pin 0 of the port. Bit 1 of these registers are associated with pin 1 of the port, and the same as for other bits. The three registers available in AVR microcontrollers for us: DDRX register, port X, and pin X. DDRX register is used for the direction register. It will set the direction of the register, and port X register is the output sending register. In this register, we have send data to port, and it will be appear as output. And PNX register is the input register, which will be using for input. Here is some theory of this. We have a DDRA 0 or 1. If you have all 1, we have 0 cross FF you can use as, and all are 0 we can use as 0 cross 0 0, as I have tell you. That is the data register configure the data direction to the port, and this register used for determining whether whether port pin will be used for input or output. Pin register, as I told you, pin register used for the read data from port pin. In order to read data from port pin, first we have to change the port data direction to input. This is done by setting bits in data DDRX to 0. If port is made output, then reading PNX register will give our data that has been output on port pins. These are two input modes. Either we can use port pin as internal pull-up or tri-stated input. It will be explained as shown below. For reading data from port A, the DDR A is equal to 0 cross 0 0. Set a port A as input. X is equal to pin A. Read contents of port A. Port X register in general, port X register can be used for two purposes: to output data when port is configured as output, then port X register is used. We set bits in DDRX to 1 corresponding to pins before becomes output pin. Now we can write the data into respective bits and port X register. This will immediately change the output state of pin according to data we have written on the ports. For example, output data in variable X port A is used as this and output is, and this is some theory. Register address or at pin 3 to 8. So output direction input and as well as you can see here. Instruction set for AVR. This is the instruction set. We can use all the command as we required, and there is used if and all the uses from is immediate instructions. Immediate instruction operates on a single register using constant value, which is part of the instruction. Note that there are restrictions to which registers can be used, and it is some commands and so we can use here. Arithmetic and logical operation is using two registers. Now we're moving to software procedure, ATMEL Studio. Click on the just we have used C in the previous video. Select, click on the similar, click on the similar project and selection we have seen earlier. You can watch the video of I will share the link of our previous video in the description you can find here, and then we have Proteus software general procedure uh, you can see in the previous video. Hardware procedure: to work on the hardware, following steps should be implemented. Write the correct code and follow the steps for software and check it on the Proteus to check its validity. Connect the Arduino to laptop PC. Then send the hex file. As we have hex here. In some cases, the Arduino do not accept like this, so we have to upload it through Xloader. We will go to Xloader, a small window will appear. This is Xloader, and upload our hex file here. You can browse it and upload our hex. Select a COM port as we have here, and then the code will be uploaded. And these are the pin connections of Arduino Uno. You can have some here data sheet you find will be on Google easily. So first task is, so here is the code, uh, Proteus implementation. We have task one, which we have load a number 30 in R16 and add it to 25, store in the next register, and then clear the register. So we can see here in code. Then we have load LDI load command R18 and output set R18 and output port B is R16. So we store 30 in R16 and send 25 into R17 and add both R16 and R17 and send the output into R16 and then clear R16. So this is the code for adding 30 and 25, and this is the Proteus simulation of task 1. Task 2, in this task, take an input from one port and display in the another port, simulate on ATMEL Studio as well as Proteus. So we have task 2 here. We have the value of R17 is 0 here, and port B as set port B as our input, and here we have control register is loading on the pin B, and the value of R16 is equal to FF. The port is now output, and R17 is loaded into port D, and it's Proteus simulation here. Here is the Proteus simulation. Here is the push buttons and LEDs and hex will upload in here. Our task 3 is this. In this task, display charging sequence of LEDs on any port simulated on ATMEL Studio as well as Proteus. We have to use display charging sequence of LEDs on any port. We can use it any port. Code. I'm skipping other group mates code and showing you my code. So here it is. Here it is my code. So first we start as a loop, and we have different set of instructions. First we have R16 as output, and port D set port D 0, and we have as we have to show the charging sequence, we have to input delay. Similarly, we will set the port B into D0 to 1 and 1 to 2 and 2 to 3 and 3 to 4, so far and so on till 7. We have 8 bit, so we will move to 0 to 7. And CBA is the clear bit uh, uh, command, and SBA is a set bit input. We can use here, and from delay we have 250 delay, and degree and DC is a decrease function which will be one by one decrease the value of the R16, and it will create delay. So here it is our Proteus simulation, and it is showing that the LEDs will be showing a charging sequence of here. The task 4. In this task, take two value input from different ports and compare them. If both values are same, show this, and on third port, if not equal, then show this. And simulate an ATMEL Studio as well as Proteus. So here's the code. Then first the take port B and C as input and D as output. We can port D and B and C are input and port D is output. You can see as 0 cross 0 0 and 0 cross FF, which will be showing as input and output. Then giving input to B and C port, R16, R17 and R18, pin B and pin C, and CP the compare command, and BREQ is comparing equal command. If not equal to, then we will show this, and if equal to this, and both are equal, then we will show this. So when we are not giving our we both are not equal, then we'll show 1100 1100. So here you can see if we have used both same, uh, you can see another yes here. Then we will show 0011 and 0011. So this is our output in both, and this is our task 5. And the last task is that write your comments about the function STS as jump, move, output, sub, inc, dic, DC, and COM port. We don't have to in the simulate this code into Proteus, so we'll just write as LDI R16 0 cross FF, output port B R16, and COM R16, and inc R16, LDI R17 to 0 cross 11, and DEC decrement of value stored in R17, and this copies the value stored in R16 into R17, and then jump code to start. This is our code for task 5. Task 6 are traffic light system, and I can show you here. So we have declared the direction of port C as output, and port B as well as output. And then pattern, we have used LDA command, and using delay we can use the traffic light system. We have first we have 01001000, and then we are using the pattern, and we can write as well these commands and write the relay function as I told earlier. We have R21 have 2255 value, and after these three registers will call the decrement and compare, and it will call declare. So this is our protest implementation. Suppose we have we have used four uh, junction traffic lights. So three are red and one is green. If this will be turning into red, then it will first on yellow, and other light will be on yellow. Both will be yellow, and then it will be green and it will be turned red. So it will work like this. It is our hardware implementation for task 1, and it is task 2, task 3 here, and this is for task 4, charging this is traffic light system. Conclusion. In this lab, we have learned the basic implementation of assembly language and its implementation, and we have analyzed different commands of assembly language that will create a difference in assembly language coding. We have done 6 tasks, including our traffic light system, comparing and storing the value registers, as well as our charging sequence, and so forth and so on. This lab have put the issues facing while coding in Arduino, and we've learned the characteristics and syntax of assembly language. Thank you so much. And if you have any query, you can ask in comment section. And don't forget to give your valuable feedback in comment section. Thank you so much. Allah Hafiz. See you in next video.